When you think about heroes, you probably think about this guy, or maybe that guy. But in the real world, there are lots of heroes who need maths in their jobs, such as firefighters, doctors, and police officers. Our world needs these heroes, and these heroes need maths.
Firefighters regularly use ratios in their day-to-day life.
Heroes compare two quantities of the same unit. Rates compare two quantities of different units.
An example of their use of trigonometry is to find the extension of the ladder from the truck to the burning building. Ladders have a safety angle which allows a certain weight on them. For example, if the angle of the ladder is 65 degrees, the ladder can hold 204.1 kilograms. Using trigonometry and the function sine, you can determine the length of the extended ladder. Sine is the ratio of the opposite side to the angle to the hypotenuse of the triangle. Say the height of the building is 6 meters and the angle of the ladder is 65 degrees. The corners are labeled A, B, and C. Using the function sine, we can determine that sine 65 is equal to AB over AC. Substituting the value of 6 meters into the equation instead of AB results into the equation sine 65 equals to 6 over AC. Using the cross multiplication method, AC is equal to 6 over sine 65. The answer to this equation is approximately 6.62 meters, which is the length of the extended ladder.
Doctors utilize mathematics in the form of both rates and ratios to determine the medicine intake for their patients. Ratios are used to create effective medicine, less or more of the ingredient depending on the intended strength of the formula. For example, in Panadol cold, flu, and cough relief formula, the ingredients they use are 500 milligrams of paracetamol, 5 milligrams of phenylephrine, hydrochloride, and 15 milligrams of dextromethorphan hybridamide, a ratio of 500 to 5 to 15. When simplified, 100 to 1 to 3, to create a successful medicine. Rates are also used to find medicine dosage for a kilogram of weight, and so on.
Imagine a scenario where police had to catch a criminal who was 25 kilometers away. The criminal is moving at an average speed of 50 kilometers per hour, and the police car is traveling at an average speed of 125 kilometers per hour. The criminals need to be caught within 30 minutes to prevent them from escaping. Even though the police car is further away than the criminal, the police are traveling faster. Using algebra and diagrams, we can solve this problem to find out if the rate the police are traveling is fast enough. This is a diagram of the current situation. The blue line represents the police and the red line represents the criminal, and the variable t is time it took to catch the criminals. Our first step is that 25 plus 50t equals 125t. Transferring 50t to the other side, we get an equation of 25 equals 75t. We use the cross multiplication method to have t on the right side and all the numbers on the left. This is equal to 25 over 75 equals t. In simplified terms, 1 over 3 equals t. Our final step is to convert our fraction to minutes. We multiply it by 60, the number of minutes in an hour. Our answer is 20, which is under 30 minutes, thus we can catch the criminal in time.
As you can see, maths is a major factor in everyone's lives.
Our
World
Needs.